All right. Let's do it then. Today is day 24, and we're going to be getting into 5.5, which is integrals. Now, calculus is basically three things. It is limits, derivatives, and integrals. In IB, limits are just like a blip, and we kind of move on after 2 days. And so we spent a whole month plus on derivatives, and now we're going to spend about a month, a little bit of plus on integrals, okay? The way I want you to think about integrals and integration is when it comes to math, there is a tried and true, this is how math works your entire life, is the first thing you learn how to do is add two numbers together. And what do you learn after you learn how to add two numbers together? Subtract two numbers. And it just works opposite of addition. It would be, 7 minus 3 equals 4. And then up next, you learn multiply, and then you learn divide. And that carries on forever, right? Then you learn how to distribute, and then you learn how to factor. And then you learn how to FOIL, and then you learn how to factor. And you always just learn how to do something and undo it. You learn how to square something, you learn how to square root something. And so we've learned how to do derivatives, which pushes us in one direction. And so now we're going to learn how to do integrals, which is just the opposite of derivatives. So think squaring and square rooting is the same connection as derivatives and integrals. So your integral, I don't know that you need to write 5 plus 5 equals 10 on your notes, but you're welcome to. Your integral is the opposite of derivatives. And so let's get at least one example on here. Let's say that the tangent x, we take the derivative of tangent x, and so you might remember the derivative of tangent x? Yes. Secant squared x. And now that's something we already know, and that means that secant squared x, if we take the integral, it's going to be taking us not forward into another direction, derivative, but backwards, and it's going to take us right back to tangent x. So, a silly question, if I ever asked you to take the derivative of something and then the integral of something, you'd be right back where you started. Just like if I asked you to square something and square root it, or if I asked you to take the sine of a function and then the arc sine of a function. It's going to go forward, it's going to go backwards, and it's going to be the same thing. They're going to cancel out. Sweet. Now let's talk about how this looks on a problem, because it's not just an arrow that says integral underneath it. Mathematicians don't like to write very much. So we know that we have this beautiful little notation for derivative. It is so easy that it is almost like you wrote it on accident. Just one little dash, and honestly, sometimes it can be confusing because it's such a small little mark that you miss it, or that you don't read it. Now, it's not as simple for integrals. You've probably seen this symbol before, whether it was in the textbook or in the formula booklet. So your function, whatever it is going to get one of these symbols in front of it. Now, how to think about this symbol? It's S adjacent, but it's not really an S, okay? You almost want to think about this bar as being mostly straight up and down. And so to be honest, a calculus, this is pretty cringe. Like we don't, especially as a teacher, that makes it look more like an S. We want, that bar to kind of be more straight up and down. That would be totally fine. As far as this works, I'll say that writing this, your first instinct might be, oh, I can make this look absolutely beautiful and flowery and just aesthetic. After you do a bunch of these, it's gonna like devolve and get kind of gross and ugly. So just be reasonable. It looks very different from many things. It doesn't look anything like any letters because it needs to be, taller. It kind of goes above the top and below the bottom as far as, so just because of the size, it becomes pretty obvious what it is, but you just want to avoid something like that. Like that isn't quite good enough. Anyways, I'm not here to yell at you about how you draw things. Probably the same for me. I'll start out drawing these and they'll be beautiful, but then eventually it'll be a Monday morning and you'll see one of the worst interval symbols ever. Now we're also going to be adding a dx to the end of our function. Now, we haven't really seen many symbols like this, like parentheses or maybe absolute values, where you have the front and the back. And especially here where it's two different symbols. This dx is kind of like your dy dx, right? That's kind of where it's coming from. It's telling you to take the derivative, or in this case, the integral, based on the letter x. We're pretty much doing only one letter integrals, especially for the next couple weeks. And so eventually, if you were taking Calc 2, Calc 3, maybe you would start to see some really complicated integrals of things that didn't just have x, and it would be more interesting. But for now, there's just a dx, and you just kind of ignore it. It's just there. All of this stuff is more or less the exact same thing as that little hash, just opposite, right? It's kind of like the first time that you see a square root, and you think that's the most complicated symbol ever, but in reality, it's just some weird symbol, who cares? So, if I show you a question, and it looks like that, I'm asking you to take the integral of f of x, which is just not the derivative, the opposite derivative. Instead of going forward, I want you to go backwards and tell me where we were before. So, obviously, we need to talk about how. And here's where you really need to learn how to do this because this is how questions work, okay? How can you take integrals? Well, the easiest way to take an integral is just to already know the derivative and what came before it and to have it already memorized. So option 1 is you're just looking at something that you've already memorized, which means I don't really have much to teach you. But for example, I could say, what is the integral of e to the x dx? What is the integral? It's just e to the power of x, right? I don't really need to teach you anything. You can know that this is the result of taking a derivative, and e to the x, okay, e to the x never changes. So you have it memorized already, you're in pretty good shape. So what about this one? What is the integral of negative cosecant x cotangent x dx? So that is the result of a derivative. Where did that come from? That is the derivative of cosecant x. We know that the co means it has a negative out front, and it's not going to be cosecant cosecant, so it's going to be cosecant cotangent. So that is a derivative that we've memorized before. And if you don't have this memorized, you're in pretty tough shape because it's not really easy to equate this to that unless you have memorized those derivatives. The last one, what is the integral of 1 over x dx? So what is something where we took the derivative and we got 1 over x? It's one of these like things that we kind of hate when we first learn about it in math analysis, and then the more we work with it, we kind of it is natural log x. Nice job. So the easiest way to do these questions, because you can be finished in 2 seconds with no extra work, is to have these memorized, particularly your trig functions, particularly your e to the x's and l to the x's. Now, if you don't have it memorized, you're gonna end up getting kind of stuck. And so maybe it's time for us to revisit those memorization stuff. What we're gonna do is we're gonna have, just like we had memorization quizzes for derivatives, we're gonna have memorization quizzes for integrals. It's not gonna be on Monday, or I should say Tuesday because we have off Monday. It's gonna be on Thursday next week. We'll have our first memorization integral quiz. And I'll give you the list on Tuesday of those. All right, so if you have them memorized, it's really not that bad. Great. Now, what if it's something that you've never seen before? So what if it is something like x power 5 plus 3x power 2? Well, that is it's polynomial, but I've never seen this exact thing before. If I asked you to take the derivative of this, how difficult would it be? Very easy. And so I'm asking you to go backwards for the integral. It probably should also be pretty easy. What rule would we use to take the derivative of this function? Power rule. And so power rule, relatively simple, relatively straightforward. What are the 2 steps for power rule? The first thing that you do, if I was gonna take the derivative of this, multiply by what?
The power.
Exactly. So we kind of have 2 rules here, right? The first one is the exponent moves to the coefficients. And I like that he said multiplies. The exponent gets multiplied by the coefficient, right? It would be 5x. And then what's the second rule? Exactly. Sub 1 from the exponent. It goes from 5 down to 4. All right, now we're not trying to learn how to do derivatives. But if we're trying to do integrals, it's just the opposites. And so here we go. Here comes our first integral. This is our rules for derivative. And in fact, we might even want to label this as the power rule for derivatives. And so what about the power rule integrals? It should be the exact thing, but totally backwards and opposite. So it should still have 2 steps. Now, for derivatives, we go first to put the exponent into the coefficient with multiplication, and second, subtract 1. And now when we're gonna go ahead and do the integral, we're gonna need to go this direction, right? Because we're trying to go fully backwards. So we're trying to go, instead of 1, 2, now we're gonna go 2, 1. So what is the opposite of subtract 1 from the exponent? Awesome. Add 1 to the exponent. Genius. And the next piece, it says that the exponent should be multiplied by the coefficient. What's the opposite of that? The exponent should be divided by the coefficient. Terrible handwriting. Okay, there you go. All right, it shouldn't be more complicated than that. In fact, I could have realistically on the last test given you a simple polynomial and just asked you to figure it out. Tell me what was the derivative before this, and honestly, you would have been able to figure this out. So let's do it. For the first term here, we have x power 5, and where did that come from? Okay, I want to take the integral of this, and the way that should look is I need to add 1 to the exponent. It's going to go from 5 up to a 6. And then, instead of putting that 6 in front, it's still going to go in front, but it's going to be divided instead of multiplied. So it's going to look something like that. Now here's the best thing about when you learn the second, after you learn how to square root something, you can always just check your answers easily by doing the first part. Does this become x power 5 when we take the derivative? Yes, because the 6 comes out front and crosses out the 6, and then we left over with 5. So checking your answer, which is every math student's worst nightmare when they're in middle school, when we're in calculus and checking your answer is this easy, we like that. Does anybody have the integral of 3x squared? X to the third power. Now, if I wanted to maybe write this because it's our very first day learning this, I would say let's add 1 so that we get 3, and then let's divide by 3. And that's why it becomes, obviously you will write onto it that the 3 and the 3 are going to cancel out, and that's why you're going to end up with just x to the third power. All right, there we go. We took our integral, and it's basically just the power rule, go in the opposite direction. Some very common mistakes, just to point them out to you. Very often, students will still subtract 1 from the power instead of adding 1. We just have such a habit of taking 1 away from the power that we'll just add 1, or we'll subtract 1 still, even though we should be adding 1. In fact, I got here on Tuesday morning when it was a teacher work day, and I was working through some of our integrals, and I printed off a worksheet off this website that is like, anyways, basically I found a mistake on a worksheet from the internet, and yeah, they just subtracted 1 instead of adding 1, right? So their answer looked like this. And for a second I thought I was going crazy because it was the morning and I felt like I was going crazy. But in reality, they just accidentally subtracted 1 instead of adding 1. So just keep your eye out for that. That is really the mistake we're gonna make. Now, I need to point out, we took the integral of this whole thing. If you remember with derivatives, whenever we had a plus, it allowed us to just kind of do them separate. We didn't have to worry about, them, how they impacted each other. And it's the same with integrals. We were allowed to basically totally ignore this and just focus on the x power 5. And then we were able to move on and only focus on this. It's the same rules. If you have addition or subtraction, you're allowed to just spread them apart and not worry about them. Now there's one more thing going on here, though. This being the integral of that, I think everything's checking out so far. X power 5, yeah, plus 1 divided by 6, okay, nice. Plus 1 divided by 3, okay, nice. There's one funky thing about integrals. What is that? When it comes to derivatives, right? Your derivatives are degrading your function. I kind of explained it to you earlier in the year, like it's kind of like a nuclear blast, right? And you only have so many exponents to protect you, and then every time you take the derivative, you're just kind of like eroding the function away. And so, when we're trying to go backwards, we have to piece together what used to be there. And sometimes that's not always possible, okay? Look at what we have here. This is a totally valid thing that if we take the derivative of this, it's going to give us that. What about if we put a plus 10? Is the derivative still this thing up here? Yeah. What if we make it a plus 100? Is the derivative still? Of course, I'm being a little annoying now. Yes. So what's going on is, when it comes to going backwards, we have this issue where we don't really know what the constant may have been before that. It could have been anything, or it could have been 0, it could have been nothing, or it could have been pi, or it could have been 10 billion. And there's really no way to know at all, okay? And so, what's going on is that when we take these integrals for the next day or two, when they're still pretty easy, and we'll learn how to handle this a little bit better, is we're going to be saying plus c. Every time you do an integral, you slap a plus c on the end, because, I don't know, plus a constant. It could be 0 if there, maybe there wasn't one, but it could be a billion. It could be negative 211, right? Who knows what it may have been. So, doing integrals are a little bit sketchy because there is some piece of information that you just can never really get back. Okay? The only way that we could maybe get this back is if they gave us more information about the original function, right? So maybe they could tell you something like, hey, well, f of 1 equals 6. And now that we have that information, we could use it to plug into the x, equal it to 6, and then solve for c, and it wouldn't be any more difficult than Algebra 1. But if we don't have this sort of information, we're gonna be kind of stuck. To be honest, once we get into the IB questions, where it's part A, part B, part C, part D, part A will probably say take the integral. Part B will probably be find c when f of 2 equals negative 8 or something, right? So that is not gonna be something we're gonna see on our homework tonight, but again, we're just kind of going through the intro. Okay, the last thing, I say the last thing. We're very near to the last thing. Is what about second derivatives? So what about second integrals, right? What if we wanted to take an integral and then do an integral again? So let's start off. Second derivative, second integral. Huh? So here we go. The integral of 5x squared minus 3x plus 1 dx. All right, we gotta do our power rule. We gotta add 1 to the exponent and divide it by the coefficient. So this first piece, I'll do it for you. Add 1 to 2 makes 3, and then divide by 3. I got 5/3 x cubed. Done. Add 1 and divide it. It's not that bad. Can somebody help me with the second piece? Add 1 to the exponent, divide it. Negative 3/2. Yep. And what about this piece? It's a 1. That's one of our kind of memorized integrals. Just x, right? Because we're taking the derivative, but not the derivative of 1, the integral of 1. So we're trying to say what gave us 1. It was just a plain old x. It's kind of like if you had like x power 0, add 1 to make it 1, and then divide by 1, and you get back here. And then lastly, I heard you guys saying you're correct. There's our plus c. Sweet. Now, boom, integral. All right, well, if we go for it a second time, add 1, you get 4, and divide by 4, I'm gonna get 5/12, because the 3 and the 4 make 12. Then I'm gonna add 1 to get 3 and divide it by 3. And that 3 is gonna cancel out with the 3 that's already there. So I'm gonna have 1/2 x cubed Or you could have, 3 over 6, which it reduces to 1/2. And then for this one, I'm gonna add 1 to make 2 and divide by 2. Now I'm gonna get plus 1/2 x squared. And then C is just a number. It could be any number. And so if I do the integral of that, it's gonna be Cx. And then plus C on the end of that. All right, so now we've done 2 integrals. It really wasn't that bad. Add 1, divide by it. No real stress here. Remember, anytime we have these like pluses or minuses, we're able to take them one at a time. So we just took it. It was pretty easy. Nice, nice, nice. But then we get here. Okay. This C, when it's just a regular old plus C, how does that affect the graph of your function? If you just have like a plus 2 on the end of it, what does that plus 2 do? It's your transformation, and it would change your y-intercept because it either moves you up or it moves you down, right? And so this function, which looks crazy, C, it could be 100 or it could be -10, but all it's doing is it's moving it up or down, right? And so if I'm gonna draw you a picture here, maybe it looks insane like that. All that C is doing here is just this. That's it. Now, when we get down here and we end up with this, we have Cx, which has incorporated that C into the x, which means that C is gonna change every time, or not, the C is not gonna change, but this function is gonna change every time x changes, which means this is no longer only moving our function up and down. This has basically crept into the function and is changing the function, and we don't even know what it is. And so this is a huge problem. This level of uncertainty is maybe acceptable, but this level of uncertainty is just blowing up the whole question, right? Because if C is 100 versus C is -100, now we're talking drastically different functions. And not only that, we have still another thing that we don't know, and we can't even really call it C because we don't know that it's the same letter, or the same number, I should say, so we can't use the same letter. And we don't really want to use D because we already have dx, and we don't really want to use E because E is a number, and we don't really want to use F because F is up there. And so this, bottom line, second integral, never. We're not really going to be taking the second integral because C is causing us a huge problem, okay? So maybe I shouldn't say never, because as long as we have C, we're never going to do a second integral. However, like I mentioned before, if they tell you that f of 0 equals 1, and then you can find C, now you're not worried anymore. Now you can go back and do a second integral. So second integrals don't really exist. It's just too much mystery, and it just doesn't work very well at all. Okay, that is a pretty, huge introduction to integrals. We've talked about how they look. We've talked about ones that you've memorized, and we've talked about how to do the power rule. And doing the power rule was pretty easy and pretty quick. We did get a little bit scared with the plus C and second integrals because we're not really doing that. Now, just for the next 30 seconds, we've only talked about power rule, and we know lots of other rules, right? We know about the product rule. We know about the quotient rule. And so if I was gonna take a derivative, let's say that I had something like x squared sine x, and I was gonna take the derivative of this, I would need the product rule, which would be 2x sine x plus x squared cosine x. Now, if I'm trying to do the integral of this, I would have to recognize all of this. I would have to recognize that it's two pieces, and then recognize that those two pieces are, one is a derivative of the other, and then I would have to go backwards and piece together that, okay, at the start, what I'm trying to tell you is product rule. Very difficult to do for integrals, right? You've got to really be on top of your game to figure out what came before it if you're doing product rule. And quotient rule, right? I mean, good luck with the quotient rule, Loki, because you're gonna be looking at something that is a giant fraction, right? And maybe it says something like, you know, x power 4 plus x squared, right? It's just gonna be an insane mess of things. And when it comes to product rule and to quotient rule, not really worrying about that right now. We might get there where we start to learn how to piece that together a little bit, but tonight, I want you to lock in on just, is this something that you've memorized before, or is this something that is a power rule? And so that means that if you see something and it says, take the integral of x squared x plus 1 dx, and you think to yourself, ooh, is this a product rule? Is this a chain rule? The reality is that stuff is a bit scary, and we'll work on getting our way there. Let's just distribute this first and not do our integral yet. That would be x cubed plus x squared. And then, okay, now this is a very easy power rule. So if you remember when we were doing derivatives, I had kind of given you guys some options and saying maybe foiling is easier, or maybe product rule is easier. It's your call. And some of us would choose different things. Some of us would choose to do chain rule instead of quotient rule, whatever. When it comes to integrals, we want the power rule. The power rule is so much easier. And if we have to do 3 steps of distribute, FOIL, simplify, and then integral, that is the path that will be easiest for sure. All right, that's the end of notes.